Okay, number 1, we have to do operations of functions. So if we start with the f plus g of x, I will simplify the like terms together. So 2x plus 1 plus x minus 3. 2x plus x is 3x. 3x. 1 plus a negative 3 is negative 2. To do f minus g of x, I might write this one out, 2x plus 1 minus x minus 3. I would recommend distributing that negative. So negative x plus 3. Then combine like terms, that would be x plus 4 f times I'll have to FOIL that. So I'll have 2x squared minus 6x plus x minus 3. So in total that's 2x squared minus 5x minus 3. And then for f over g of x, I've got 2x plus 1 over x minus 3. I cannot simplify that. There is a domain restriction here because we can't let the denominator equal 0. So x could not possibly be 3. If x was 3, the denominator would equal 0. So I would have to stipulate that here, that x cannot equal 3. Okay, number 2. Same thing. So f plus g. Let's add like terms. X squared and x squared makes 2x squared. 7x is the only linear term. 13 and negative 9 make 4. For minus, I might not write this one down because I'm running it a little short on room. So x squared minus x squared is 0. That goes away. 7x minus, there's no like term, so I have 7x. 13 minus negative 9 is 13 plus 9. That's 24, positive 24. Okay, with x squared plus 7x plus 13 times x squared minus 9, I'm going to take and distribute my x squared. I'm going to multiply x squared to each of the first 3 terms. So x squared times x squared is x to the 4th. X squared times 7x is 7x to the 3rd. X squared times 13 is 13x squared. Now I'll distribute or FOIL the negative 9 through. Negative 9 times x squared. Negative 9 times 7x, negative 63x. And then 3117 minus 117 looks like it'd be. So when I combine like terms, x to the 4th plus 7x cubed plus 4x squared. Is 4x squared minus 63x minus 117. I'm going to run out of room. Should have given myself a little more room. Minus 117. Okay. Then for the fraction, more room there too. X squared plus 7x plus 13 over x squared minus 9. I could see if I can simplify this or factor this, but this numerator is not factorable because 2 numbers are multiplied to 13 and add to 7. It's not possible. So even though the denominator factors, there's no common factor to cancel out. But I can give a domain restriction because the denominator can't equal 0. So x cannot be equal to a positive or a negative 3. Both a positive and negative 3 would give me a 0 in the denominator. That would be a problem. Okay, number 3, we're starting to do the compositions. G of h of x. So G of 3x squared. So we've got 3x squared plus 6. Give the domain and range. Oh, sorry, domain. There's no restriction there, so all real numbers. As far as the range, this one's opening up. This is a parabola opening up, so its y is greater than or equal to, and if we do negative b over 2a, we get 0. Plug that in, we get 0, 6. 0, 6 is the vertex, so 6 is the lowest it ever gets. For h of g of x, we're going to take 3 times x plus 6 squared. When you square x plus 6, you can't distribute, you have to FOIL that out. It ends up being x squared plus 12x plus 36. And then we have to turn around and distribute the 3. So we get 3x squared, 36x, 108. For the domain, all reals. The range, I'm going to need to find this vertex. So if I do negative b over 2 times a, I get negative 6. So if I plug in negative 6, I might grab a calculator. Oops. Okay, let's try this again. 3 times negative 6 squared plus 36 times negative 6 plus 108, we get 0. So my vertex is negative 6, 0. So my range, it's opening up, so y is greater than or equal to the 0 then. For number 4, G of h of x. 2x plus 3. Okay, negative 16x minus 24. Domain is all reals. Range is all reals. And then we'll do h of g of x. So 2 times negative 8x plus 3. Negative 16x plus 3. So domain and range are both all reals. So now on start with number 5, we start plugging numbers in. So we're doing h of f of 5. So if I start with f of 5, look at the f function, that's 3 times x, but here in this case it's going to be 3 times 5, which is 15. So we're doing h of 15. So now look at the h function, x squared minus 1, plug in 15. So 15 squared minus 1, 15 squared is 225. So I have 225 minus 1 is 224. And then f of, so h of 8. So look at the h function, plug in 8. So it's 8 squared minus 1. So that's 64 minus 1 is 63. So plug that into the f function. So 3 times 63, that should be 189. And then lastly, g of f of negative 1. So f of negative 1, okay, f of negative 1. So we have 3 times negative 1 is negative 3. So I'm doing g of negative 3. So it's negative 3 plus 4, which is 1. Number 8, you have a coupon for $200 off a computer, and they're on sale for 20% off. So we're looking at looks like the order of doing the discounts. So X is the original price. Use function notation to describe your price using only the coupon. So if I'm using only the coupon was $200 off, I have X minus 200. It's function notation for the cost with only the discount. So g of x, so I would get 20% off, which really means I'm paying 80%. The quickest way to do an expression or an equation for that is to think about what you are paying. You're paying 80% of the actual cost. So form the compositions of functions if you use the coupon first. So that's f of x. So I'm doing g second, g of f of x. So g of x minus 200. So that means take 0.8 times x minus 200. Distribute. So 0.8 x minus 160. Form the composition of functions if you use the discount first. That's that's f of g of x. So f of 0.8x. So I'll do 0.8x minus 200. It's the original. So which of those two is better? Before I even get to E, I already know that it's better to take 80% and subtract 200, so D is going to be better. But if the original cost was $1,250, would you pay less for your computer if you used the coupon first, took the 20%, or took the 20% discount first? So this one's better. In both cases, I take 80% of the cost, but then I subtract $200 or subtract 160. I'd rather subtract 200, so I would rather do the discount first. If you wanted to plug in the 1250 to find the different numbers to help you compare, that's perfectly fine, but I can see it in the function, so I don't need to do that. All right, now find the inverse, graph the original and its inverse. So if I graph this original right now, I can do that. And then we'll also need to find the inverse. So that's where I switch it to a y, switch the variables, and then I would solve. So I'm going to add 2, so 3y equals x plus 2, divide by 3, so y equals 1/3 x plus 2/3. If I put it back in function notation, it would be saying f inverse of x is equal to 1/3 x plus 2/3. Okay. So plus 2/3 would be about there. Rise 1, run 3. Rise 1, run 3. And go down 1, back 3. Down 1, back 3. Okay, number 10, x squared plus 3. 0, 3 is its vertex. If I plug in 1, I get 4, 1, 4. This would be negative 1, 4. If I plug in 2, 4, 7. 1, 2, 3, 4, 5, 6, 7. There's the original. So now for the inverse, switch out the x and the y. Subtract 3, x minus 3. square root. We have to do a plus minus since I square rooted. So inverse of f of x is plus minus 3. Now, table of values, there's two of them here, because I got the positive and I got the negative. If I do positive x minus 3, make a table of values, I have to start with 3, and then I'd plug in 4, and then I'd plug in 7. 3, 0, 4, 1, 5, 6, 7, 2. And then for the other one, plug in the same values, but I get 0, negative 1, and negative 2. So if I graph those together, I get the full picture. Page number 11. Alright, so now switch it to a y. Switch the variables. So 2/3 y is equal to x minus 2. I've got to distribute, or multiply by the reciprocal, 3/2. So y equals 3/2 x minus, I just get 3. So go back to function notation. 3/2 x minus 3. Okay, so all of these look like, yes, they do in fact, they are reflections across the line y equals x, so I'm confident that I did my inverses correctly. Okay, I'm going to make a second video for part 2. That's the end of page 1.